morning and welcome to Rent-A-Friend Radio. This is your affable host, Rent-A-Friend 2000, here at Rent-A-Friend Radio. It's Feedback Friday, and so I'm going to respond to one of the comments I got from my faithful listeners/readers/viewers. Super Sableye asked the question, and I'm going to paraphrase here. Is it possible that we could lose enough genes through genetic entropy to evolve back into monkeys? Now, the reason why this came up is because we were talking about reasons why evolution doesn't work, reasons why the observations go against the evolutionary theory, and one of the things that we observe is genetic entropy, which means that whereas evolution requires an addition of new genes through unguided natural processes, what we actually see is an effect of the second law of thermodynamics, things breaking down. So genetic entropy means that we get mutations, and we pass those on to the next generation, and they get mutations, because every time your cells reproduce, they copy the DNA, and occasionally there's errors. And sometimes those errors get passed on, and they add up. Now, they'll use the phrase neutral mutations in order to refer to these things, and the evolutionary hope is that enough neutral mutations will add up into new information. But that's just kind of ridiculous. It's far more probable that genetic mutations will add up from what we call neutral into harmful mutations. So the idea of a neutral mutation is kind of a misnomer, because something's been misspelled, something got corrupted, something has gone wrong. Some of the information that was there is gone. So one of the reasons why mutations don't work as a mechanism of evolution is because how many misspellings does it take to turn the recipe for a cup of flour into the recipe for a wedding cake? It's a non sequitur question, provided I'm using the phrase non sequitur right. I don't know, it's French, it sounds right, look it up. The point is you need to add a lot of information. Your recipe for cup of flour gives you cup of flour, but you need to add a whole bunch of other ingredients to wind up at wedding cake. Just spelling flour wrong won't do it. Eventually, if you spell it wrong enough times, it'll be useless. You won't have cup of flour anymore, you'll have nothing. So all that comes back to genetic entropy. We're watching the genome of every living thing on Earth get worse. Misspellings are adding up. Things are becoming more and more unreadable. So things eventually will go extinct. So is it possible that our genome could break down to the point where we become apes? Well, two things. Number one, the way I phrased the question here, is it possible for our genome to break down until we evolve back into apes? I want you, my loyal listeners and readers and viewers, to start listening to the way questions are phrased. Back into apes. The evolutionary assumption is built into the question. One of the things that creationists and Christians in general have to face a lot are skeptical questions that have assumptions built into them. And if you're facing any question at all, whether it's in a debate or just in a textbook, think about what it is the question is assuming. In this case, if the question is phrased this way, is it possible for us to evolve back into apes? The assumption is we have evolved from apes in the first place. Now, I don't know that Super Sableye actually phrased it that way, and I'm not going to say that he did, and if he did, maybe it was just an accident. Whatever, the point is, listen to the way questions are phrased, and think about what's being assumed in the question. Now, is it possible for us to lose enough genes through genetic entropy to become apes? The answer is no. It's a very good question, and I'm glad he posed it. The flat answer is no, and the reason why, there's a couple of reasons. The first primary reason is that human is not just ape with some other genes added on. There's a lot more going on than just you have a monkey and you add some genes and you get human. There's a lot of changes that have to be made. New genes have to be added. And in fact, that's true of any kind of a lot of species, but especially kinds. So things that on the evolutionary tree are different. So ape is different than man. Chimpanzee is different than man. And we have genes that only exist in humans. They're called orphan genes. In any kind of animal, they have a gene, or they have genes that only exist in that kind of animal. Clams have orphan genes. They are genes that only exist in clams. They don't exist in what the evolutionists would assume to be their closest living ancestors or relatives. And so, whereas evolution would assume you take some kind of animal and you do a little bit of addition and a little bit of addition, and that gets you a new kind, you actually have to have entirely brand new genes that don't exist anywhere else to get any kind of animal. When we started noticing this 10, 15 years ago, people thought, well, it's a fluke. When we get enough genomes mapped, we're going to see that these orphan genes are the rarity, that it's not true of all living things that they have genes that unique. But the trend has continued. And so, in order to get any living thing that's of its own kind, you need some information that's very specific to that kind. So, number one, it's not just a matter of adding genes onto monkey to get man. And number two, there are genes that are unique to each kind, so you would have to add those genes back onto our genome. So the short version is, you would have to take away those genes that make humans uniquely human, and then you would have to add on those genes that make chimpanzee uniquely chimpanzee. So there are genes that we probably have in common, because a gene is a set of information that codes for particular proteins. And so if we have some proteins in common, which all living things do, then we'll have some genes in common. And people will be like, well, chimpanzees and humans are 99% identical in their DNA, which is wrong for a host of reasons. For more info on that, see So You Think You're a Chimp, a Crevo rant by Ian Juby over at the Wazulu channel on YouTube. A couple of short reasons why that's wrong. Number one, the chimp DNA is actually 13% longer. And so you're saying that two things that are 13% different are only 1% different. So math right alone tells you that's wrong. Secondly, when they come up with that number, the first thing they do is they exclude orphan genes, so they don't consider those at all. And they exclude all of the DNA that is not coding for proteins, which is most of it. So they first exclude the genes that are unique, and then they exclude most of the DNA, and just take those couple that are coding for the same proteins and then compare that. And you're like, oh, okay, yeah, it is similar. But if you do that, we're 50% the same as a banana. So it's not really that surprising that we and the chimps would come out the same after all of that maneuvering. So the long and short of it is, it was a very good question. Thank you, Super Sable Life, for writing in. Thanks to all my other viewers and listeners for sending in comments. But could we ever devolve into monkeys? No. It would take a huge amount of genetic tinkering in order to get a human to lose enough human genes and gain enough monkey genes that we could be a monkey. It doesn't mean we can't act all monkey sometimes. You people all act like you all fell out of trees last week. Come on, people! It's time to love your neighbor. It's time to think rationally. It's time to do the right thing. Well, I'm Rent-A-Friend 2000. Thanks for listening, thanks for writing in, and above all, thanks for letting me be your Rent-A-Friend.